Assalamualaikum warahmatullahi wabarakatuh. In this video, my group from RAS 1205H will present to you our case study of gas chromatography. For introduction, gas chromatography is a technique for separating components based on their volatilities, which is based on differences of boiling point. In gas chromatography, the components of a vaporized sample are separated as a result of being partitioned between a mobile gaseous phase and a liquid or a solid stationary phase held in the column. Gas is called carrier gas. Typical carrier gas such as helium, hydrogen or nitrogen. Pressure from a compressed gas cylinder containing the carrier gas is sufficient to create the flow through the column. There's four main components in gas chromatography instrument. First, basic component that we got is carrier gas tank. The carrier gas tank function is to supply the gas that will be used as the mobile phase for the gas chromatographic separation. The carrier gas is typically supplied by a conventional gas cylinder. However, the carrier gas is sometimes supplied by a gas generator coupled to the gas chromatography apparatus. Next component is sample injection system. The injector has a heated chamber with a glass liner into which the sample is injected through the septum. When the injector is in split mode, the carrier gas enters the chamber and can exit via three paths. Third component that we got is column. The column is the heart of gas chromatography. Separation can occur due to interactions between solids and the stationary phase within the column. In column, the analyte will undergo separation process by obeying the principle of separation. The principle of separation is like light dissolve light, where light refers to the polarity of the analyte and immobilized liquid. There are few factors could affecting gas chromatography separation. One of the factor is volatility of compound, where low boiling point components will travel faster through the column than the high boiling point components. Last main component of gas chromatography is detectors. The purpose of detectors is to detect components of the mixture being eluted from the chromatography column. There are two sorts of detectors, destructive and non-destructive. Non-destructive detectors should be used in gas chromatography.
Biodiesel was prepared from the extract of seed oil of Datura stramonium by two-way process comprising of acid catalyzed esterification followed by base catalyzed transesterification. The fatty acid composition of the biodiesel sample was analyzed by gas chromatography coupled with mass spectrometer. The gas chromatographic analysis was made using Agilent series chromatograph equipped with a mass spectrometer detector. The gas chromatographic system used in this paper is mass spectrometry. Next, the injection was performed in split mode with a split ratio of 50:1. A capillary column of 30 meter times 250 micrometer times 0.25 micrometer dimension packed with non-polar HP5 column was used. Helium was used as the carrier gas at the flow rate of 0.8 mm per minute. The column temperature was programmed initially at 100 degrees Celsius, held for 20 minutes, and then increased to 180 degrees Celsius at rate of 10 degrees Celsius per minute, held for 10 minutes, and then increased to 200 degrees Celsius. The sample was diluted in hexane and 1 microliter of this solution was injected into the column. Lastly, the mass spectrometry detector was operated in the positive electron impact mode with ionization energy of 70 electron volt of accelerating voltage in the ion source.
Today I will present about result and discussion. Chromatogram shows the fatty acid methyl ester of the Datura stramonium. Out of all the peaks found in the Datura stramonium, we only highlight 4. 2 of them are oleic acid and allylic acid, which are the major components found in Datura stramonium. The other two peaks are caprylic acid and lauric acid. Molecular weight of oleic acid methyl ester and allylic acid methyl ester are the same, which is 296.5 gram per mole. Meanwhile, caprylic acid methyl ester has a weight of 158.24 gram per mole. And lastly, lauric acid methyl ester molecular weight is 214.34 gram per mole. That's all from me, and I will pass to Nabila MYSARA to continue the discussion.
Based on the molecular value that was mentioned by SHAMIMIE earlier, I'm able to find out the elution order of the 4 fatty acids methyl ester of natural stramonium peak that we choose from the chromatogram. Elution. What is elution? Elution is a process in which species are washed through a chromatographic column by addition of fresh solvent. As in this study, it is referred to the process in which fatty acid methyl ester are washed through a capillary column by the addition of hexane. The elution order of the 4 fatty acids methyl ester can be related to their molecular weight, boiling point, and volatility. The higher the molecular value, the higher the boiling point, and thus the volatility of the fatty acid methyl ester will be lower. The lower the volatility of any fatty acid methyl ester, making the fatty acid methyl ester to be eluated longer or later than others. Based on the molecular weight value that was listed in the table earlier, caprylic acid methyl ester has the smallest molecular weight value, which is 156.24 gram per mole. The smallest molecular weight value of caprylic acid methyl ester between the other fatty acid methyl ester chosen make its volatility the highest, and thus caprylic acid methyl ester is the first compound to be eluted. Following caprylic acid methyl ester, lauric acid methyl ester placed second in terms of molecular weight value with a value of 214.34 gram per mole. The volatility of the lauric acid methyl ester is lower than caprylic acid methyl ester. However, they are still higher than oleic acid methyl ester and allylic acid methyl ester. Hence, this makes lauric acid methyl ester to be the second one eluted. Next, oleic acid methyl ester and allylic acid methyl ester share the same molecular weight value of 296.5 gram per mole. They share the same molecular weight value as they are cis-trans isomer to each other. Allylic acid is the trans form of oleic acid. Based in the highest molecular weight value, this cis-trans isomer's volatility is the lowest. However, both of them has different boiling point. Allylic acid methyl ester has a boiling point of 351.45 degrees Celsius, which is lower than oleic acid methyl ester. The lower the boiling point of a fatty acid methyl ester, the higher the volatility of it, and thus, this making allylic acid methyl ester is the third to be eluted based on the lower boiling point. Meanwhile, oleic acid methyl ester boiling point is 353.0 degrees Celsius. The higher the boiling point of the fatty acids makes the volatility of the fatty acid becomes lower. Hence, oleic acid methyl ester will be eluated later than allylic acid in terms of boiling point and the last to be eluted between 4 of them. So, the final elution order of the fatty acids will be as below. The first one, caprylic acid methyl ester. Second, lauric acid methyl ester. The third one, allylic acid methyl ester. And lastly, would be oleic acid methyl ester.
In the conclusion, the study reveals that biodiesel samples with high monounsaturates, mainly methyl olate, can exhibit better fuel properties in terms of ignition quality, cloud point, and heating value. Engineering the fatty acid composition may offer a quality biodiesel which is yet to be explored.